Let's pause for a moment so we can share some exciting news. We're proud to announce that our work here at Bring Back the Porch is getting noticed. From October to the end of January, our videos and reels viewed more than 1 million times. Some of those viewers could be your customers, so sponsoring Bring Back the Porch is a great way to get your message in front of them too. If you'd like to support our work here at Bring Back the Porch, we ask you to go to our website at bringbacktheporch.com and follow the links. Thank you for your support.
Arm's length, we opened up and we're pushing down. We anticipate that hose is going to slide back. So we're not trying to keep it muscled and not move at all. Anticipate the nozzle reaction is going to come back on about 1 to 2 inches. So if you start with your hand slightly forward, open that bail, that nozzle or that hose is going to come back. We're pushing here.
This episode of Bring Back the Porch brought to you by Bernie Leahy, River Street Realty. Let's get you home. Nolan, beautiful day for training here. Explain what is happening.
Today what we're doing is a Nozzle Forward course. So recently we put a committee together and we evaluated our hose and nozzle packages, and we found some things that were lacking. Just the new construction with homes are getting hotter, so we want to make sure we get enough fire or enough water on the fire and it's easy for our members to maneuver. So we've made a switch to a different hose and nozzle package, and today we're going through the crew members on different advancement techniques and how to use the new equipment.
How much different is it from the old equipment?
Significant, I would say. They both did the job, right? But now we're finding we need more water to put out the same fires just because of how hot and how fast they're burning. So we've switched to a similar flow, an exact flow actually to what we were using before, but we're able to cut our pressure back and make it easier on the guys to advance. And the nozzle reaction's less, so less chance for injury. We can be quicker, get fires out faster.
So less fatigue for the firefighter as well?
Yes.
Okay. Just sort of describe what it feels like when you're holding the new nozzle compared to the old one.
Well, the old one, we used to use an automatic nozzle. Now we've moved to a fixed. So the automatic nozzle, there was also a risk to it. It would adjust our stream patterns and we wouldn't know if there was a problem, right? It would feel like everything was great, right? And you wouldn't know that you were actually short water. Now with this new fixed, it's more constant. The nozzle reaction, because of the new hose, is less, and the guys are able to move it in and be quicker and easier on the guys.
Are all the nozzles the same? Do they do the same thing, or do you have to have different nozzles for a different fire?
We're able to narrow it down too. That's the other thing, is we wanted to kind of simplify it. So now we can go with two different nozzles on our attack packages, and we don't have to worry, it'll react the same. It's easier for our pump operators, easier for our officers. We kind of made it more simple.
I think the old ones had a pistol grip, and the new ones look like they have just like sort of a slide.
Yeah, we've went away from the pistol grip. It's something that you're seeing more and more in the industry now. It just our reason for moving around is it eliminates the chance of bad habits and kind of pushes proper technique. Also, it's extra weight on the end of the hose, so you can get a nozzle whip, which is dangerous. So when they're flowing water, if that gets out of balance, the nozzle actually can whip and hit the fireman.
Is there a set pattern for each nozzle, or is it adjustable depending on the situation?
We have smooth bore now and fixed with a fog, but really the fog is honestly only for ventilation. So we're always going to have it in a straight stream when we're actually actively fighting a fire.
Okay, we're in a situation where there's a house on fire and you're going in. With these new hoses, do you attack the fire differently than you would have before?
No, so the hose doesn't change our strategy and tactics, which that's probably changed the most in the last 20 years they've been here. Our strategy and tactics have changed a lot. We're getting a lot quicker, a lot faster. We're getting fires out, quicker with less water. But we could have done that with the old hoses too. right? It's a lot more work, it's more dangerous, and there's more chance for things to go wrong, from the pump to the backup guy to the guy on the nozzle.
Hauling these hoses around different than the old ones?
There would be a difference, I guess. So, the size of your hose, and then when it's charged, is bigger. So this hose actually is about 1/4 of an inch, I believe, smaller than our old hose. So you're actually dragging less water behind. So we're getting the same flow, we're dragging less weight.
You sometimes have to fight wildfires. Will these nozzles be more efficient or less efficient?
We'd use a different package for that if we can. We will use these sometimes, right? This is a big hose to be dragging around. We have wildland hose that's different. You have to be careful. We do use our structural hose when we have to, obviously, in the coulees and stuff, but it can burn through better, where a wildland hose will actually sweat and, stops that a little bit. So different application.
You mentioned that the water pressure is different. Does that have any impact to where you are getting your water source from? For instance, a fire hydrant might have a set pressure that but maybe you're using a pumper truck or
We are
something.
very lucky in this city. This city's done, I'm sure everyone's seen it a lot. There's been a lot of construction and replacing old hydrants and water mains. So we have a lot of hot hydrants in this city, which is maybe something that the public doesn't notice, but it is a huge advantage to other cities. So we don't have a water pressure. Lots of times our engines are almost choking the water back.
Okay.
So we're very lucky that way.
When you're on the front end and you've got that nozzle in your hand, how can you explain the different technique you use with the new nozzles compared to the old ones?
The techniques, I guess, are similar, like what we're doing. This just lets us do it safer and quicker. We have more control. We don't have, with the old pistol grip, you used to have to have it tucked in close to your body, and you'd really have to twist, right? Because our hose had too much. If you put the hose out in front like we are now, you'd have too much nozzle whip. Whereas now we have really good control. We can 180, turn left, right, super fast. It's significantly better when we're moving through like tight quarters in a house, making tight turns.
And does it allow you to do different patterns easier?
You can do. We stick to a couple main ones, right? There's only a couple that we actually use, but yeah, you have way more control. We call it, a push or a flow and go, and it's safer, quicker, and easier with this new package.
Explain that term, push, flow, and go.
So if now, because fires are getting so hot, we have to be flowing water while we're advancing to cool gases. So with this new package, it just makes it a lot easier for us to do that. Rather than flowing, shutting down, advancing, flowing, shutting down, we can be moving constantly.
What has the team learned from their hands-on experience?
So it's first morning in it. We've had a few crews go through. Lots of different techniques. It's not far off of the basics of what we're doing, but it's more getting everyone moving together, make the job a little bit easier, a little bit safer.
Nozzle Forward Program.
Yes.
Can you describe what that means?
Yes, the Nozzle Forward Program is a systematic approach to engine company operations. It was developed by Aaron Fields. He primarily worked out of Seattle, Washington. So it's a collection of practices to advance the engine company operations in the fire environment.
Fires are changing all the time. Is this a result of that?
I don't think it's really a result of the changing environment, but it's a systematic approach to the environments that we meet, whether they're changing or not. So it provides firefighters an algorithmic approach to be able to decide whether they can advance into the fire environment or stay where they're at. And really, it allows the firefighters to make solid decisions with the environment that they've found
and support the mission of protecting the community and the people inside the fire.
The nozzles, as I can see in the background, they look like just they have a lever on them. Are they different from the old ones?
These ones, the mechanics of the nozzle are the same, so that's called the bail, and the bail's opening and closing the same pattern and the same mechanism, but these ones don't have a pistol grip on it. So the department has decided that they're changing and upgrading hose and nozzles, and that's kind of the genesis of today's training, and that allows us to focus more on the mechanics of the hose operation rather than just holding the pistol grip.
Have you had hands-on experience with this?
Absolutely, yeah. I work at a small department, or I worked at a small department in Port Angeles, Washington, and we went through a very similar battery of testing to get to our hose, and it's nice to see somebody that puts the same amount of hard work and passion into serving their community as these folks do.
What happens when a hose gets a kink in it?
So it can occlude the flow by 50% or more if the level of kink is about 90 degrees or more. So that was one of the parameters that Medicine Hat tested their hose, was to see not just how much pressure they're losing, but how many gallons per minute they're losing. And so they decided on this hose because it didn't occlude the flow near as much as other manufacturers.
When the firefighter is in a room and it's fully involved, can he tell just from what he's seeing coming out of the nozzle if he's losing pressure or if he has enough water?
Large variations in pressure can be felt on the hose, whether it's in their old configuration or the new one, but small variations, and I would define small as 10 to 15 psi, is negligible on the feeling. And your question also includes the supposition that we could see in the fire environment.
Yeah.
But so typically we can't see in that environment.
Yeah, so that's important. Then you have to have this, I guess, this feel, this sixth sense when you're in fighting a fire.
Well, and part of the process that Medicine Hat has overtaken in the last year or so is to include the pump discharge pressures, and they're upgrading all of that. So firefighting is very much a team sport. So if I'm inside fighting fire, I'm trusting that the pump operator is providing me all of the adequate pressures to get all the water I need, and they've undergone that in training as well.
In the training, you've got people with various levels of experience. Do they sort of default back to what they like, or are they open to new procedures?
Well, that's what we're here today. The Nozzle Forward Program is great at giving the newest member an algorithmic decision-making pattern under stress, so they can make the same decision as the officer would with all the experience, and it allows the members to make decisions based on what the environment's providing them rather than their level of experience.
Do you give them a grade?
No. No, most of this is determined by their passion, and their passion kind of drives them when they're tired at the end of the day to keep going and get more repetition in, and the more repetition they get, the better they end up with their skill set.
Well, in my experience, I've never met a firefighter who didn't want to go right to the very end and more. So it's good to know that they have that stick-to-itiveness.
Exactly.
Thank you, Andy.
You bet. Thank you.
New training, new techniques. How's it been going, Scott?
It's good. So Nolan and I, the gentleman you interviewed prior, was part of the committee that did some hose selection. So we were introduced to this last year, and we were fortunately through the committee and the recommendations, we were pushing forward with a change of our hoses and nozzles. And so what this is about is that we have all the hoses and nozzles here. They've been ordered, they've been purchased, and after this week, everyone in the department will receive the training, and then they go on the trucks right away.
How are they different from what you're used to?
So these hoses flow at a different pressure. Our older hoses, with their optimal flow is at 100 psi to get 150 gallons a minute out the end of the nozzle. These flow at 50 psi to get 150 gallons a minute out the nozzle. So it's half of the pressure.
Does that impact how you fight a fire with less pressure?
So the flow is the same. The goal, the idea of this is that we're going to be moving and flowing at the same time. So in our old hoses, there's a lot of nozzle reaction. When you open the nozzle and you're flowing water, it wants to push backwards on you. So it's quite a bit of effort to maintain stationary, let alone trying to advance moving forward or backwards. What this new hose is that we're still flowing the same amount of water, but with half the amount of pressure. So the techniques, we need to learn how to handle that hose, but the less pressure affords the opportunity to move with it. So move forward or move backward or move up or downstairs.
Does that also impact the fatigue level of a firefighter?
Absolutely, yeah. We train for the extremes, but we're only human, right? So it's definitely teamwork. There's a lot of technique in this, how you advance hose down stairwells, how you advance hose down hallways, how you advance hose around corners. So it's not a one person doing the job. It's a team of people doing it's a crew. So there's different commands we use and different techniques to make that the most efficient.
Construction methods are changing, the materials they're using are changing. How's that affected firefighters?
So when I started 22 years ago, I think we would call it, there's legacy construction or there's modern day construction. Modern day construction, it was around, it was prominent, but maybe not as prominent as it is today. So with new home construction and man-made products, engineered products that are lots of glues and resins and particle board, and with the idea of the legacy construction is more compartmentalization. So there's lots of different rooms in a structure versus nowadays, or you have the opportunity with those engineered products to have larger open areas. The downfall of that is that the products are engineered. So there's gusset plates, there's fasteners, there's glues, there's resins, there's processes how they do it, where they press it, that contributes to fuel. It increases the fuel load, it increases the speed at which it burns, and the heat release rate that is released. So a legacy construction building that would have standard dimensional lumber of a 2x4 or a heavy timber construction doesn't burn as readily as it would be today.
Now they have laminated beams too, and that's full of resin and glue. Does that also accelerate a fire's growth?
Absolutely, yeah. So it burns, it degrades quicker, and it contributes to the fuel load.
And if it's a supporting beam,
correct.
It's let
yeah.
go.
That's right.
Yeah, but you don't know that going in.
Well, we study building construction. There's cues that architects and carpenters, there's windows tell you a lot, doors tell you a lot. We spend a lot of time studying building construction and the features, and you should have a good idea what the floor plan is going in before you go in, based on what you see from the outside. So it's not always the case. The permitting process for renovations is there for a reason, and some people don't follow it. So sometimes when you open the door, you don't expect, or you don't get what you expect.
With the trend in a lot of renovations now for open concept, does that also change the way a fire burns and grows?
It'll change for sure how it spreads. So obviously reducing compartmentalization would increase the spread because there's nothing there to stop it. So you would have fire in areas maybe you would not expect it as quickly there, or you'd have more fire when you're entering those places.
Okay, when you go into a fire, time is of the essence. How fast does a fire grow?
Well, they used to say, not used to, but with modern day construction, they say it doubles every 30 seconds. I think the science is even leading it to be quicker. So if you think of a bedroom might be 200 square feet, a 10 by 20 bedroom, which is a pretty moderate size bedroom, that's a pretty big bedroom, and if that area were to double every 30 seconds, our response determinants get us on scene in 6 minutes and 20 seconds for the first arriving unit, but that doesn't mean we're entering the structure at that time. That clock starts when somebody dials 911. So, we're on scene in 6 minutes and 20 seconds by the time we get our hose off the truck and then make entry, whether it be unlocked or locked. That can delay us, and then find the seat of the fire. We're talking 7-8 minutes. So if it doubles every 30 seconds, it's got a pretty good jump on us.
So you have to be able to be mobile and quick.
Correct. So through safety, for keep ourselves safe, and then through efficiency and buying state-of-the-art equipment and tools that allow us to perform the best we can.
These new hoses, do they make the job easier?
They make it more efficient. It's still a lot of work. It doesn't make it easier in terms of effort. The effort is still there, but what it does is it allows you to have more reserve. So advancing hose and then doing work on the inside, I think what it does is allow you to have more reserve so that you can do more work for longer inside, because we only have as much air as on our backs. We're pretty cognizant of the levels, whether it's full, 3/4, half, or a quarter, and different how much air we and how quick we use it. So I think it's allowing us to do the same amount of work with less effort, but it doesn't reduce how hard the work is.
What about the service life of a fire hose? Does it have an expiry on it that has to be replaced over a certain number of years?
No, actually there isn't. So we have hose still from the 1980s and 1990s. What determines the service of life of a hose is how it's treated and how it's inspected and cleaned and maintained. So all of our hoses tested annually, and there's industry standards that we test every piece of hose. And if it fails, then we can either repurpose it, or we can make it shorter. We can get them recoupled. If the failure is near a coupling, we can get it recoupled, and it becomes shorter, and we just put it in a different spot. As long as it's cleaned properly after use and maintained, they'll last forever.
When you come back from a fire, what's the procedure for the hoses? Are they rolled out and dried, hung to dry? What do you do with that?
Yeah, so we definitely clean them. We have hose washers. We can use a mild detergent if they're severely soiled. We try and choose colors. When I first started, we had colors that were white and yellow, and they're bright colors, but they dull over time. We purchase hose that's orange. The color isn't necessarily, doesn't make it stronger or weaker, it's just for identifier. So we have different colored hoses on our trucks because they have different purposes. So when a hose comes off a truck, we know what that function of that hose is when it's laying on the ground by its color.
Okay. When you're on the nozzle, compared to the new ones that they're training with now and the old ones, is there a different technique you have to use? Like, do you use your arm more, your body more, your hips more? How do you work? How does that work?
So we moved away from pistol grip, so we don't have a built-in handle on the nozzles anymore, so we have to learn how to hold the hose and pinch it and clamp it to our bodies. So that technique is new and different because we can't rely on the handle of the pistol grip. As far as flowing, I think this affords us more opportunity to flow in multiple directions without a lot of movement. So with the pistol grip, which would be tight in towards our body and limited mobility, we could, this hose can be moved up, back, up, down, backwards, and behind us. We could quickly maneuver and flow in a lot of different directions without having to change our grip.
Is it hard to train for the new hoses?
Well, I guess
muscle memory being
I'm an old dog and I'm trying to get new tricks. So I think for the younger fellas that maybe don't have as many years of bad habits, they might pick this up a little bit quicker. So I'm trying to break old habits and trying to learn the new techniques.
You talk to other fire services that use these new hoses. Do you get tips and advice from them as to how?
Yeah, we certainly did. So our logistics people and our training officer training division last year, when they were entering this process, they talked to a lot of other departments around Alberta and Western Canada and the northern United States. The reason that the other captain and I were chosen for the committee is we attended a conference in Rocky Mountain House where they had instructors there from all over the United States and Canada, as far away as Toronto. And what they were introducing was all of this concept and techniques, and it's not necessarily, I think there's maybe a fallacy. This isn't new technology. It's actually going back to the way it was. If you look at the old nozzles that was in the first nozzles of the fire service, none of them had pistol grips. They were the exact same nozzles that we have now. There's a real discussion on whether it's a combination nozzle. So a combination means I can create a straight stream or a fog out of the same nozzle, or a smooth bore. So there's those two basic functions, and through science, through the Underwriters Laboratory and the UL down in the United States, they've done an immense amount of science and study on this with all of their thermal couplers and controlled burns, and there's not a lot of difference. So it becomes down to preference. There is a reason for smooth bore in the fire service, and that more lends to like itself for high rise. So when you're hooking up to standpipes and existing infrastructure that's already in buildings, there's a lot of debris in terms of what people might have put in there, or debris in terms because of how old they are, and the water lines themselves are degrading, so that it has to pass that debris.
You got to be able to get it out.
Yes.
Yeah. Water pressure, does that, from the hose, when you're in fighting a fire, does a certain water pressure needed to put a fire out? I'm just thinking if somebody's got a garden,
So there's no,
that's not going to do it.
yeah, there's not there's no conversion factor in saying if it's this pressure you're flowing this flow, but that's how we do measure flow, is through pressure. So we can put a pitot gauge inside, which is a way of testing. You introduce this gauge into the stream, and you can gauge how much water's coming out. So then each appliance we apply it, whether it's a nozzle or something else on the end of the hose, is rated for a certain flow, but it's all based off pressure. The hydrants that supply our service in the city, the average residential home or fire hydrant would be around 60 psi, and we need to flow that into our truck and then through all of our waterways. And the longer the hose is, the more pressure you need, because there's friction loss that goes along with it. So the smaller a hose is, the more friction loss there is, so then you reduce pressure. So then you play around with different size hoses. So we spec this hose as an 1 3/4 hose, or a 77 millimeter, but the way that it's constructed, it actually swells and gets bigger when it's filled with water and up to operating pressure.
I'm just thinking Tim Taylor going in to fight a fire, he wants more power. Yeah. So if you had, say, 100 psi coming out of that nozzle, would that put a fire out faster than if you only had 75?
Well, what I just said would probably say that is true, but with the technology of this hose and the nozzle we chose, is at 50 psi we're getting the same flow.
Yeah.
So.
Good. Okay, anything else you wanted to add, Scott?
No, I just thank you for your time.
Thank you for the information.
You're welcome.